Okay, remember on these types of problems, real life problems about a parabola, most of the time your input is going to be about time, like the time since you dove off the diving board, the time since you kicked the soccer ball, the time since we launched the rocket. The y values are usually about height. On rocket problems, you're probably not going to be able to see this if you're in Zoom 6. So I do want you to practice changing your window. I'm going to reset my calculator. When I'm doing a real life word problem, I always adjust my window. My x min and my y min, my time minimum and my height minimum. 0 is what would make sense. I usually back it up to -1 for x minimum and y minimum. For x maximum, that's my maximum time. That means the time until it lands. I usually start guessing around 15 seconds. For maximum height, that's my y maximum. I usually start guessing around 200 or 150, and I just see if I can see it. I'm going to put my equation in. Y equals -3x squared plus 36x. What's the y-intercept of this equation? 0. What does that mean? It was launched from where? The ground. It wasn't launched from a platform. It was launched from the ground. It's going to go up to its highest point and then come back down. Okay, so I already changed my window. And let me see if I can see it. I can see it just fine. And in fact, I could probably make my y maximum a little shorter. You don't have to, but I just like my picture to look nice and pretty. Okay, so there's my picture. Now, all kinds of questions that I can ask you. Look at number 1. When will it reach a height of 65 meters? Am I giving you an X or a Y here? A Y. I know it's a Y because it's a height. And I'm asking you for a time. I'm asking you when. So I am asking for an X, but I'm giving you a Y. Where do you go if I give you a Y? You go to Y equals. I want the Y value, the height value, to be 65 meters. It's going to happen twice. On your quiz, I'm going to break this apart into 2 separate questions. I'm going to ask you when is the first time it gets to that certain height. That's on the way up. That's this one. And when is the second time it gets to that height? That's on the way down. So on the quiz, it's going to be broken apart. On the warm-up, I just said, when's it going to get there? It's going to get there twice. So we got to find both. Calculate where it intersects. My little cursor was closer to the second time. So the second time would be 9.785 seconds. Please just give me 3 places after the decimal. Don't worry about rounding or anything. That's the second time it gets that high. That's on the way down. Trace over to the other side of the vertex, and then we'll find the first time it got that high. Second function, calculate intersection. First curve, second curve, guess. 2.214 seconds was the first time it happened. Are we good with that? Please give me the unit. I think that helps you when you're trying to figure out if you're looking for an X or a Y. Please write the units on your quiz. Look at number 2. What will the rocket's height be after 4 seconds? Yeah, I'm giving you a X, and I'm asking you for the Y. Because I'm asking for a height, and I'm giving you a time. I can do that in table set, or I can do calculate value. You do calculate value when you know an X value. It's asking you, what do you want X to be? I want my time to be 4 seconds. What's my height when that happens? 96 meters. I also could have done table set, and I could have told my table to start at 4 seconds. Oops. And then looked at my table of values. Sure enough, at 4 seconds, it's 96 feet high. Okay, look at the next question. What is the highest distance the rocket will reach? What am I asking for there? It's definitely about the vertex. Specifically, what part? The Y value. So I've got to find the vertex, but if I want to know the highest height, the only part of the vertex I care about is the Y. I can do that 2 ways. The calculator can find the maximum for you. You can do second value, calculate maximum. It's going to ask you for a left boundary. Make sure the cursor is to the left. Then it asks for a right boundary. Scroll over till you're to the right. Now remember, the X value is not perfect. Some of you are giving me, Julio, I think you are, giving me the wrong X value. The X value is not really 5.999. It's really what? It's really exactly 6, but I'm not asking for the x value right now anyway. I'm asking for the y value. What's the maximum height? 108 meters. Now look at the next question. How long will it take to reach its highest distance? That's the x value. Again, if you do it in the calculator, it's going to give you a weird number. The exact x value is the opposite of b, which is negative 36, over 2 times a. And negative 36 divided by negative 6 tells you the x value is really exactly 6 seconds. Now, here is the one kids are still struggling with. When will it land? What am I asking for if I'm asking? It's going to land right here. That is a root. I'm asking for the second root. I'm asking when is it going to land? It's going to land with a height of 0. That's a 0 of the function. How long is it going to be in the air? How long will it take to land? The time until it lands. That's all asking about a root. How do I do that? Y equals 0. And then I calculate where they intersect. So it's going up, 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 reaches its maximum height, starts coming down, it lands right here. First curve, second curve, guess. How long? 12 seconds. So how long is it in the air? 12 seconds. How long until it lands? 12 seconds. Now, on the quiz, I do ask you to give me domain and range of the situation. This is a word problem. The domain in a word problem situation is not going to be all real numbers. That's if it is a plain old parabola that goes on forever, but this thing does not start under the ground and come up and then burrow into the ground and go on forever. It starts on the ground, it ends on the ground. Okay, so let's talk about domain. Remember, domain is x values. In this case, time. What's the lowest time? 0. That's before we launch it. What was the highest time? 12. That's when it landed. That was the x-intercept. And all the other x's are in between. That's the domain. Range. In this case, range doesn't have just one endpoint like a normal parabola would have, because it stops. It lands. It doesn't burrow into the ground. What is the lowest y value? 0. That's the ground. What's the highest y value? 108. That was the y value of the vertex, and all the other y values are in between. Now, if this wasn't a word problem and I just gave you the equation with no real life situation, then the domain would be all real numbers and the range would be anything less than 108. But this was special. It was a real life problem. It didn't go on forever. Are we good with that? I will ask you that on the quiz. Okay. One more situation. I just made these numbers up. I don't even know if it would really make a parabola or not, but I've labeled all. This is a rocket going off into the air. Can you tell me where this rocket started? It started on a 5-foot platform. Well, that is the what? Y-intercept. The y-intercept is at 0 time. It's at 5 feet. So before we even began taking the time, it was already at 5 feet high. What if I asked you, how long does it take to get to its highest height? 4.5 seconds to get to its highest height. What if I asked you, how long is it in the air? 9.3 seconds, which is the root. What if I asked you the highest height this thing will ever reach? 280 feet. What if I asked you the domain of this function? Okay, now some kids said 5. 0. 0 is the lowest time. Is less than or equal to x, which is less than or equal to 9.3 seconds. This is the whole time it's in the air. Now be careful on range here. What's the range? Some kids told me 5 was the lowest y value. Well, if it went straight up and straight back down and landed on the platform, then yeah, 5 would be the lowest y value. But it starts at 5, that's true. But did it ever get lower than 5? Yeah, when it landed. It landed on the ground. We're going to assume it landed on the ground. So the lowest height would be 0. What's the highest height? 280. And all of the other heights, all of the other y values are somewhere in between. Are we good with that? Okay, I do want to talk to you about the homework. I know you guys were rushed yesterday. We're not even going to grade it today because of the pep rally and all that fun stuff going on. But I do want to tell you what I expect, and I do want to give you some hints. This again is about something going into the air and then coming back down. A diver, a soccer ball. Okay, so first of all, we're only doing the side that said problem solving. I'll help you with all of these. Let's talk about number 1. Everybody reset their calculator, please. Number 1 says an Olympic diver. Oops, let me reset. Second plus 712. An Olympic diver is diving off of a high dive, and his equation can be modeled by this. Negative 3x squared plus 6x plus 24. Where is this diver starting? He's starting 24 feet above the surface of the water. How do I know that? The y-intercept. He's starting at a height of 24. He's gonna jump and go up, and then eventually gonna come back down and hit the I hope not the ground. Yikes. The water. The water is like the ground in this case. Ramiro, you better be paying attention. Your grade yesterday was not good enough for you to be sleeping right now. All right. So here we go. I put that in. I'm in Zoom 6. I'm probably not going to see very much of this. I know I'm not going to see very much of it because my high dive is only going up to 10. Plus, I got all this negative business that doesn't really make sense in this problem. So let's adjust our window. What's my minimum time? 0, but I usually put -1. My maximum time? I don't know. Let me see. Can I see him coming down? Yes, I can see him coming down. 10 seconds to get to the water is enough. Because imagine a diver hovering in the air for more than 10 seconds. That'd be crazy. Okay, height. Window. Let's talk about height. The Y minimum. I'm going to make it -1. The Y and X minimum usually in real life situations usually are at 0. But I usually back it up to -1. Y maximum. Well, I know he's going higher than 24 feet because he starts at 24 feet and he's going to jump up a little bit. I'm going to make it 35 feet. Okay, so really the part of the picture I'm concerned about is here where he is at 24 feet. He's going to jump up and go up to his highest height, and then what happens right here? He's hitting the water. It does ask you to graph this. So on both of these, guys, I want you to find the vertex and I want you to find the positive root. Because you need that to do the graph. So you're going to have to, I know 0, 24 is on the graph, but you're going to have to figure out the vertex so you can put a dot there, and you're going to have to figure out the y-intercept, the x-intercept, so you can put a dot there. Then you've got the picture. Okay, you know a parabola is a curve, so at least give me the vertex and the root. So you're going to have to find that anyway. But then look at the word problem it asks you. In the 2 little lines it gives you on the bottom. Answer the question. Look what they're asking about the diver. How long does it take the diver to reach the water? What's the only thing they're asking me? How long to reach the water? What time are they asking me? The root. Where does he reach the water? Right here. 0 is the water. They're asking you when will the y value be 0? When will his height be 0? He's 0 at the water. So that's an x-intercept question, which you should have found anyway, so you could graph this for me. Then you come over here to number 2 about the soccer ball. Look at the soccer ball's equation. Y equals -16x squared plus 48x. Where is the soccer ball being kicked from? The ground. How can I tell it's being kicked from the ground? The y-intercept is 0. There's no y-intercept there. It's like a +0 on the end. So I know one of the zeros, but that's really not the one they're going to ask me about. What am I going to have to find to graph it? I need you to find the vertex for me, and I need you to find the other root. Okay, so you need to find those so you can give me a nice picture. Then look at this question. Find the maximum height. What are they asking you for there? They're asking you for the y value of the vertex. Then the next follow-up question says, how long does it take to get to its maximum height? That's the x value of the vertex. Did it ask me when the ball lands? No, it could have though. What is it asking for if it wants to know when does the ball land? That's when it wants the root. Remember, y-intercept is where it starts. X-intercept is usually where it ends, or how long it took to happen. And vertex is the highest it got and the time it takes to get there. Okay, and then on numbers 3, 4, and 5, it's all about the model rocket. And in the question, they tell you the highest the rocket gets. Do you see the highest that the rocket gets? They give you some points here. What's the highest that it gets? 259. And you can draw the y-intercept in and then answer the rest of the questions. Part 4, this number 4 bothers me a little bit. It says, how long will the rocket be in the air? And it's not really an exact answer because it didn't start on the ground. But just count over, and you should be able to find the best answer of when it's in the air. Count over from the vertex. Only one of those answers would even make sense. Then look at number 3. I skipped number 3. It gives you 4 more points, and it asks you which one of those points would be in line with the graph. Well, it's got to be in line with the pattern that this graph is taking. So if you graph those 4 points, you're going to see one of them makes sense and the other 3 don't. Number 5. Then they want you to come up with the equation. And you can do this by process of elimination. What 2 should you be able to eliminate right away? A and B. Zoe, wake up. Jaquan, handle it. I'm about to have a conversation with your mother. Why can I eliminate A and B? Because those have positive values of A, which means this would be a smile situation, which obviously this is not a smile situation. The other 2 that are possible would be C and D, but if you look closely at the y-intercept and closely at the picture, only one of them will make sense. So that's how you can answer those, even though we didn't have the equation to begin with. All right, your homework is to make sure you finish that 9-3 worksheet on the problem-solving side. And then all we're going to do for the rest of the period is the quiz.